Question 5, Part B. Consider the curve given by y equals 7 plus 4x cubed minus 3x to the power of 4. Part 1. Find the coordinates of the two stationary points. To find the x coordinates of the stationary points, we first differentiate y with respect to x in the original function to find the gradient function y dash. We then solve the equation y dash equals 0 to find those x coordinates. Once we have those x coordinates, we substitute those values into the original function to find the corresponding y coordinates. So differentiating y with respect to x, we get y dash equals 12x squared minus 12x cubed. Solving y dash equals 0, in other words 12x squared minus 12x cubed equals 0, we can simplify this equation by dividing all terms by 12, and we get x squared minus x cubed equals 0. Factorising out x squared from the terms on the left hand side, we get x squared times 1 minus x in brackets equals 0. And by the null factor theorem, we arrive at the solution x equals 0 or x equals 1. Now when x equals 0, using the original function, y equals 7 plus 4 times 0 cubed minus 3 times 0 to the power of 4, which equals 7. And when x equals 1, y equals 7 plus 4 times 1 cubed minus 3 times 1 to the power of 4, which equals 8. Therefore, the two stationary points have coordinates 0, 7 and 1, 8. Part 2. Find all values of x for which d squared y over dx squared equals 0. To find the second derivative d squared y over dx squared, or y double dash, we can differentiate the first derivative that we found in part 1. So from part 1, the first derivative y dash equals 12x squared minus 12x cubed. Differentiating y dash with respect to x, to get y double dash, we get 24x minus 36x squared. Solving y double dash equals 0, we get 24x minus 36x squared equals 0. We can simplify this equation by dividing all terms by 12, and we get 2x minus 3x squared equals 0. Factorising out x from the terms on the left-hand side, we get x times 2 minus 3x in brackets equals 0. And by the null factor theorem, we arrive at the solution x equals 0 or x equals 2 over 3. Part 3. Determine the nature of the stationary points. We can use the first derivative y dash to determine the nature of the stationary points, where y dash equals 12x squared minus 12x cubed. So the two stationary points are located where x equals 0 and x equals 1, and we found that in part 1. So we test around those stationary points. We draw up a table of gradients, and from those table of gradients we can determine the nature of those stationary points. So the values of x that I've chosen around x equals 0 and x equals 1 are x equals -1, x equals 1 over 2, and x equals 2. So we know that when x equals 0 and x equals 1, the value of y dash, or the value of the gradient, is 0 and 0. When x equals -1, the value of y dash is 24, so that represents a positive gradient. When x equals 1 over 2, the value of y dash is 3 over 2, and again that represents a positive gradient. And when x equals 2, the value of y dash is -48, which represents a negative gradient. So from the table of gradients, the stationary point at 0, 7 is a horizontal point of inflection. And we can see that from the gradients that I've drawn here under the values of y dash. So it goes up, across, and then back up again. And the stationary point at 1, 8 is a local maximum. So it goes up, across, and then down. Part 4. Sketch the curve for the domain x greater than or equal to -1 and less than or equal to 2. The question is asking us to sketch the graph of the function y equals 7 plus 4x cubed minus 3x to the power of 4 in the interval x greater than or equal to -1 and less than or equal to 2. Now we're sketching the graph of a polynomial function. Its degree is 4, so it's a quartic polynomial, and its leading coefficient is -3, so it'll be a concave down graph. Now when x is equal to -1, y is equal to 0, and when x is equal to 2, y is equal to negative 10. And they represent the endpoints of our graph. Now, in previous parts, we found the stationary points 0, 7 and 1, 8, and we determined their nature. The stationary point at 0, 7 is a horizontal point of inflection, and the stationary point at 1, 8 is a local maximum. So here is a sketch of the graph y equals 7 plus 4x cubed minus 3x to the power of 4. And we've shown here the horizontal point of inflection and the local maximum. And we've also shown the location of the endpoints of our graph, which is negative 1, 0 and 2, negative 10.